Hello friends. So today very interesting topic. Today we are going to see two topics in the video. The first aspect is the type of mirrors. If you find this video slow, you can put it on the fast mode. It will go like you can see that speed. But anyway, let's see the other topic. The other topic is sign conventions. If there are any mistakes in my spelling, please forgive me. You can write in the comment that these are the errors, and I will try to see if I can edit the video and then correct it later. Okay, so today's discussion is going to revolve around two topics. One is the type of mirrors and other is sign conventions of the mirrors. So this forms the foundation. These two aspects forms the foundation of mirror solving problems in physics. Which problems? Like ray diagrams and image formation as well. Okay, this forms the foundation for your ray diagrams and image formation as well. So we are going to cover these aspects. So let's move on to the type of mirrors. This is the first topic we are going to cover. So type of mirrors, I'm going to write it down here again anyway. Type of mirrors. How many type of mirrors do you know? From your daily use, how many types of mirrors have you actually observed in the real world? Can you tell? Which mirrors? Can you tell?
Plane mirror.
Plane mirrors, very good. Plane mirrors, and which is the other type?
Spherical mirror.
Spherical mirror, wonderful. So under spherical, what are the type of mirrors you encountered?
Concave mirrors.
You have concave and
Convex mirror.
convex. So basically you have 1, 2, 3. 3 types of mirrors that we are going to study. We are going to study each of these mirrors in slight depth. We are going to see what type of image is formed and where they are where the image is actually being formed. So let us take the plane mirror first. A plane mirror is a flat structure. It's a flat structure. It's a straight structure. If you see it, it is something like this. Right? On one side it is polished. I will polish it on the right side. This side it is polished. And this side it is shiny. So when an object stands here, for example, if you stand in front of the mirror, and when you see the mirror with your eyes, when you see the mirror, you actually see your image. But this image is not formed right onto the mirror. It is actually formed at the depth inside the mirror. You'll see yourself as if you are behind the mirror. Right? And because your image is behind the mirror, this is a virtual image. And the size, one aspect is the virtual image. The second aspect is that they are of the same size. And if you are standing at a distance of 2 meters from the mirror, then the image is also formed at a distance of 2 meters. Right? So the ray of light comes like this, and the other ray of light comes like this, and it actually diverges. This is the incident ray, and the ray diverges out. So it appears to meet backwards. It appears to meet behind. It appears to meet behind the mirror. So this is as far as the plane mirror is concerned. Next we move on to concave mirror. If you can imagine a concave mirror, it's like a gufa, it's like a cave of a tiger. Sorry, a tiger doesn't have cave, I guess the lion has a cave. So a concave mirror is like a den. But how is the concave mirror actually carved? If you actually take a sphere, this is a sphere. As you know, concave mirror is part of a spherical mirror. On this sphere, I polish the sphere on the outer surface. What do I do? What do I do? I polish on the outer surface. Right? This is polished. And the inner surface is shiny. Right? So now if I cut this sphere, this way I cut, or I cut this way, or I cut this way, or I cut this way, it all gives me a concave mirror. So one shape would be like this, wherein the outside is actually polished. Other one will be this way, wherein the outside is polished and the inside is shiny. The other one will be this way, and the outside is polished, inside is shiny. And the other mirror will be something like this, inside shiny and the outside polished. So all these are concave mirrors. They are concave because it is curvy on the inside, right? The shiny surface, that means the reflecting surface, is on the inside. The inside of the inside is actually the reflecting surface. The inside is actually the reflecting surface. Hence it is called concave mirror. I hope this is clear so far of how a concave mirror is actually carved out. Next we'll see for convex mirror. Now we'll take the same sphere back again. In case of concave, we polish the outside surface. Now in case of convex, we polish the inside surface, inner surface. And the outside is the reflecting surface. Now if I have to cut, if I cut two parts, then I have two pieces of mirrors. One piece is like this and the other piece is like this. And if you see, the polished surface is on the inner side. Polished surface is on the inner side. This is the inner side. Polished surface is on the inner side. And this is the reflecting surface. This is the reflecting surface. Shiny surface. Only when you see yourself on the shiny surface, then only you will be able to see your image. That means your image is formed on the outer side of the circle, on the outer side of the mirror, right? It's curved as if you take if I draw like this, then you can imagine a spoon. This is kind of a spoon, wherein the outer surface is actually the reflecting surface. So this is for convex mirror. So now we are going to see the sign conventions for concave and convex mirror. So let's take concave on one side, and on the other side we'll take convex. So as you know, the concave is reflecting on the inner side. So I'll take the concave mirror like this. Pardon me for my accuracy of the curve. The outer surface is polished surface. And in case of convex mirror, the inner surface is polished surface. The inner surface. Here the outer surface is polished, here the inner surface is polished. Now if I have to see my image on a concave mirror, if I have to see my image, I have to stand on the reflecting side. Right? I have to stand on the reflecting side. And on the convex mirror, if I have to see my image, then I have to stand on the reflecting side, which is this side. The reflecting side is here, and I have to stand on the reflecting side, on the same side of the reflecting side. Here as well, on the same side of the reflecting side. So now this mirror is actually carved out of a sphere. Right? It actually, you can imagine a sphere here. Not a perfect sphere, but you can just imagine it. And here also it is carved out from a sphere. So every sphere has a center, right? So the center of this mirror will be somewhere here, and the center of this mirror will be here. So you have to always imagine a sphere, right? Of a sphere, the mirror is actually cut out, and this is the center. Both these are centers. This is the center of convex, this is the center of concave. Center. It's also called as the radius of curvature. Pardon the spelling. Radius of curvature. Radius of curvature is the distance from here to here. From the center to the surface here, which is called as the pole. This center here of the mirror is called as the pole, denoted by P. This center here is called as the pole, denoted by P. Or is it pole? It's called pole. Now between the center of the mirror and the pole lies something called as the focus. In between, exact halfway distance from the center, halfway distance from the pole is called as the focus. Here as well, halfway distance from the center, from here to here if you take halfway, and from here to here if you take halfway, you will have something called as the focus. This is called focus. This is called focus. This length here, from here to here, this length is called as the focal length. What is it called, dear students? Focal length. And the distance from center to pole is called radius of curvature, right? We already noted it on here. Radius of curvature, right? And this line here, which joins the center of the mirror and the pole of the mirror, is called as the principal axis, PA. मिरर का PA, ये मिरर का PA है. पर्सनल असिस्टेंट, नॉट पर्सनल असिस्टेंट. Principal axis. The line joining the center to the pole is the principal axis. These are the main sign conventions, right? Now we'll see how the actual denotations are. Whether the length from the focus, from the pole to focus is positive or negative. The distance from pole to focus, is it positive or negative? Let's take a fresh slate I'll draw it again. Concave, convex. Polished outside, same here, polished inside. This is the pole, this is the pole. This is the center, assumed center. And now we want to know whether focal length is positive or the radius of curvature is positive, the image distance is positive, or the object distance is it positive or negative. How to represent it, we are going to see in this particular session. So now, as we know, if the reflecting surface is on the inner side, the object would stand somewhere here. And wherever the object is, from there the incident ray will traverse. That means from the object, the incident ray will traverse this side. For convex mirror, the reflecting side is this side. So the object would stand somewhere here. So the incident ray of light would traverse this way. This is the incident ray. This is the incident ray. This is the focus. This is the focus right in between the center and the pole. So now if I am measuring any distance, I have to always measure from the pole. Distances are always measured from the pole. Distances always measured from pole. From pole, always measured from the pole. This is a common mistake which most of the students do. While representing the sign of any distance, you have to remember that it is always taken from the pole. That means from the pole, you need to see in which direction you are moving. If you are moving from the pole, and if you want to check the focal length, that means the focal length of a concave mirror is on the left side. So that means I am traveling against the incident ray. I am moving this way. So if I am moving towards the left, as you know, if I am moving towards the left, I am moving against the incident ray. So if I am moving against the incident ray, the distance should be considered as negative. If I am measuring from the pole towards the right, that means along the incident ray, then the distance measured is positive. Similarly, on this side, if the object is standing here, if somebody is standing here, opposite to the reflecting surface of the convex mirror, then the incident ray is this way, moving from right to left. Now the incident ray is moving from right to left. That means all distances are actually measured from pole to focus. So the focal length of a convex mirror should be positive or negative. So I traverse along the incident ray. So if I am going along the incident ray, then focus would be this side. All the dimensions to the left of the pole will be positive, and to the right of the pole will be negative. If you observed here, there are certain denotations. U is called as the distance of the object. Object distance. And V is called as the image distance. So if you notice here clearly, the object is placed on the left side. So all the distances measured from right to left for a concave is negative. That means the object distance U for concave is actually negative. What about U of convex? U of convex, is it positive or negative? The object is placed on this side of the mirror, on the right side of the mirror. So that means you're traversing from the pole going towards the right, which is against the incident ray. And because you're going against the incident ray, we know that all directions, all distances measured against the incident ray is negative. So the object distance is negative. Similarly, focal length. Focal length for convex would be positive. Focal length for concave would be negative. What about radius of curvature for concave? Radius of curvature for concave would be negative. Radius of curvature for convex would be this side, right? Radius of curvature is measured from the pole to the center. So it is positive. So these are the key sign conventions of a concave and convex mirror. I hope this is very clear enough. The concave mirror, I'll clear this slate and now we'll go to a slight depth of certain other terminologies. The concave mirror is called as a, what it is called? Concave mirror is called as a converging mirror. And why is it called converging? If I take a concave mirror, polished on the other side, that means polished on the outer side and reflecting on the inner side. That means all the rays of light which come parallel to the principal axis. This is the principal axis. This is a personal assistant of the ray of light. So all the rays of light, we know that this is a polished surface. So the ray cannot traverse further out, cannot traverse this side. It has to bounce back. It has to bounce back. And it bounces back this way. How do we know it should be this way? How do we know that the ray of light, when it bounces back, it should bounce back this way? Think and write in the comments. How do we know if the ray of light which is parallel to the principal axis should bounce back downwards and not upwards? It should not bounce upward. This is the wrong. It should not bounce upwards. This is wrong. This is the correct denotation. Please think and answer why the ray of light actually which has gone parallel actually bounces back downwards and not upwards. Please think and write in the comments. Okay, so because the rays of light converge at some particular point, and we are going to study this in the rules of the rays, what is this point called? But because nevertheless, because it's converging, that is why it is called as a converging mirror. In case of a convex, I'll take a convex mirror now. Convex mirror is polished on the inside and the outside is reflecting surface. So rays of light coming this way parallel to the principal axis. Principal axis is pole to center. All these rays of light come parallel to the principal axis. All these rays actually diverge from the mirror. And why do they diverge? Please explain in the comment section. And I'll take a separate video to explain why they actually diverge in case of a convex and why they actually converge in case of a concave. So now, because they're diverging, they appear as if the rays of light actually come from inside. This we are going to see more detail about the rules of ray formation and also as well as the image formation in the subsequent videos. But because the rays diverge, convex is called as the diverging mirror. So now that we have seen all the sign conventions and we have seen the different types of mirrors. Let us see a quick formula. What is the formula which we can represent for all these mirrors? So the mirror formula, is given by 1 by f is equal to 1 by v plus 1 by u. F is the focal length, v is the image distance, and u is the object distance. This is a mirror formula. So next we are going to take up another video for just formulas and some problem solving as well. We are going to see other formulas like magnification as well. M is given by minus V by U. This is a magnification term. It is also represented by M is equal to height of the image divided by height of the object. These are the two formulas for magnification, and this is a mirror formula. So time to wrap up. So let's see what all we have studied today. I'll clear this slate for now. If you want to note down, you can note it down. I'll summarize quickly. So we have seen plane mirrors. In plane mirrors, we have same size image, virtual image. Then we have seen concave mirror. Right? The reflecting side is inside. In concave mirror, just to give it in brief, images can be either real or virtual. We are going to see this in the subsequent sessions as well in more detail about real and virtual images and how they are formed. And then we saw about convex, reflecting on the outer side. And then we have seen all the sign conventions. Here we saw that if the incident ray is moving from left to right, then all the directions measured from the pole towards this side is actually negative, and from the pole towards this side is actually positive. So this is all in today's session. So next we are going to see the rules of rays in case of a concave and convex mirrors. So keep in touch and please subscribe to the video, and please suggest any suggestion that you might have to make this video, make this session more visual. So we are going to see live experiments as well in the subsequent videos, where we are going to take mirrors, actual plane mirrors, and we are going to see the reflection of a candle or maybe ourselves as well. So keep looking forward to have a wonderful session with you all. See you, bye.